Welcome. In this video, we're going to talk about the vertex form of a quadratic function. So vertex form looks somewhat like this. So we have a function f of x, and the vertex form, I'm going to write an example off to the side. Maybe we had an a value of -2. And maybe inside with the x, inside the square, notice there's a square, maybe inside with the x we have a -3. And maybe outside we have a +4. This quadratic function, it is quadratic because the x is squared, and you could multiply it out and put it in the standard form, the ax squared plus bx plus c, but we're not going to do that because it's actually easy to graph from this vertex form. So what we know is that for this particular example, because a is -2, the parabola is going to open downward. So direction of opening, if a is positive, it opens up. If a is negative, it opens down. And then the vertex is h comma k. Well, so for this example that we have, this is x minus h. So h is 3. Line them up. The x lines up with the x. The minus signs line up, and the h must be 3. So h is 3. And here's the plus k, so k is 4. Now notice what happens. So for this example, the vertex is 3, 4. So let's talk about why that happens that way. So when we have a real number squared, notice the square right here. When we have a real number squared, smallest that can get is 0. And when is that going to be 0? When x minus 3 is 0. And then when that part is 0, the rest of this becomes 0. So what we have is a y value of 4, because it's 0 plus 4. So that is as high as we're going to get, because any other x value, we're going to be adding something negative to that 4. So our vertex in this case would be a high point at 3, 4. Our axis of symmetry, remember the axis of symmetry is always the vertical line through the vertex. So once you know the vertex, you can find that equation for the axis of symmetry. If your parabola opens up, you'll have a minimum. If your parabola opens downward, you will have a maximum. The domain is always going to be negative infinity to infinity, unless we have a real life application where we need to work with different domain. But when we're graphing just quadratic functions, the domain is going to be all real numbers. And the range is going to depend on whether that parabola opens up or down. If the parabola opens up, you're going to have a minimum y value, but it's going to go up forever. If the parabola opens down, you're going to have a maximum y value, but from there it will go down forever. And we'll see this in the examples. It's easy to find the domain, the range from your graph. Okay, so let's go into example 1. So for example 1, a is -3. So that parabola is going to open downward. The vertex, I like to look at it this way. The vertex is going to happen when the inside of the square, this inside the square, when the inside of the square is equal to 0. That's going to happen when x equals 4. That's actually the equation for my axis of symmetry. And then the vertex, I need to find the y that goes with the x. Well, if we plug in 4 for x, we get this piece turning into 0, and 0 plus 7 is 7. So the vertex, h comma k. So there's the a, there's the h, there's the k. H is 4, k is 7. The maximum or minimum, because it opens down, we have a max value Remember, if it says value, we want just the y. The maximum value would be the 7. If we want a point, then give the point 4, 7. The domain is going to be all real numbers, negative infinity to infinity. And the range is going to be from 7. Oh, wait, this one's opening down. So the domain is all real numbers, but the range is from negative infinity up to 7, which is our largest y value. And we have our information. And you can do the graph sooner if you would like to. I'm just going to go ahead and put the vertex on the graph. So we'll just count 2, 4, 6, 2, 4, 6. So we've got 4, 7. There's 4, 7. Maybe we'll do that in the blue. And then we can plot other points as well. Like we can find out what happens when x is 5. And if you plug in x equals 5, you find out that the y value is 4. Use the symmetry line to find the point 3, 4. I'm going to draw that symmetry line, just a dashed line through the vertex for our symmetry line. I've also talked to my students about the 1, 3, 5, 7 pattern that we can use when a is 1. And then when a is, in this case, negative 3, we can use the 3, just multiply them all by 3, 3, 9, 15, 21, but we're going down. So from the vertex, we go to the right and down 3. Then from that point, we go to the right and down 9. So there's 4, 5, 6, 7, 8, 9. From 4 down 9 would take us to negative 5. Or you can plug in x values. I can plug in x equals 6 and find out that the y value is negative 5. Because 6 take away 4 is 2. 2 squared is 4. 4 times negative 3 is negative 12. Negative 12 plus 7 is 5. And then we'll draw our parabola through those points. Its sides are pretty steep because of the 3, opening downward because a is negative. And that's the first example. Let's dive into the second example. We have f of x equals 5 times x plus 8 squared minus 3. So here's our a. A is 5. I need to look at this as being x minus negative 8. See that plus sign? Subtracting a negative. And then adding negative 3 is the same as subtracting 3. To be careful when I calculate the h and the k, or when I find the values of h and k. Direction of opening. This one is upward because a is positive. Okay. The vertex, h is negative 8. So a couple ways you can look at it. You can remember that x plus 8 is x minus negative 8, or you can just look and see what makes that equal to 0. And that gets you your axis of symmetry and also the h value for the vertex, the x-coordinate of the vertex. When you plug negative 8 back into our function, this is going to be 0. 0 squared is still 0, times 5 is still 0, and 0 take away 3 is negative 3, so the y-coordinate of vertex is negative 3. So we have our vertex. We're going to go ahead and put that on our graph. So I'm going to go 2, 4, 6. Negative 8 is way down here. You could count by, you could use a different scale if you wanted to. I think I'll just count by ones on both the x and the y-axis. Okay, so we've got negative 8, negative 3. There's 3. Negative 8, negative 3 is right there. I'm going to draw the axis of symmetry in. And then I'm going to use, I'm going to put in negative 7. I'm going to show you how to plug values in. So if x is negative 7, the y value that goes with it is going to be 5 times, let's see, negative 7 plus 8 is 1. We've got 1 squared, which is 1. That's going to be 5 times 1. 5 minus 3 is 2. So when x is negative 7, the y value is 2. We'll put that point on the graph. We'll use the symmetry to find another point on the other side. And this is going to be a really steep parabola because a is 5. All right. I could use the 1, 3, 5, 7 pattern, but I have to multiply it by 5. I get 5, 15, 25. From the vertex, I go 1 to the right and up 5, but if I go 1 to the right and up 15, I'm off the charts already. So I'm just going to draw the graph through those points that I have and make it steep on the sides because that a value of 5 makes it very steep. I seem to be skipping a little bit with my pen. And there's our parabola. We need to finish up the information over here. The maximum, we don't have a maximum, we have a minimum value. We'll just abbreviate MIN for min. We have a minimum value of negative 3. The domain is all real numbers. The range is from negative 3 to infinity. And that is the end of 6.4 notes.